Good morning, everyone. We are going to do some problems on stack this time. Um, and I hope you guys got a chance to look at the problems we will be discussing. So my idea is to begin with a simple, introduction of stack a little bit. And then I have a question for you. If you guys went through the questions, can you tell me what in particular we are going to talk about? Anyone?
Like increasing or decreasing arrays.
Yeah, that's right. So yeah, like a stack is used, like we can use it in so many ways, but this particular session is focused on, we can call it monotonic stack, and we will go through the concepts and we'll go through some problems and we'll see how to apply those concepts in those problems. So with that, let me start sharing my screen. Okay, so you guys can see my screen, right? Let me make it bigger. Yeah. Okay. So can someone tell me in general, when do you need to use a stack? And what is a stack? Like, it's not a very super basic session we are going to have, but which kind of like data structure stack is? It's good to start with that. So yeah,
Last, first out.
last in, first out. Yes. So stack is last in, first out. That's right. I'm assuming like, you guys know about this already. So when do we need a stack is, what does that mean? Last in, first out. So, okay, some of the things I put in my stack here, 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 and then whoever came last actually came first, it will stay here for more time than the guys who are coming on top, right? When can we need that? Like if you see when programs are running and you do, for example, recursion. So if this guy depends on anything I'm doing here, it depends on something here, then this guy has to wait here, right? So similarly, programs also create their own like function stack, same concept. It has to wait till these guys finish. This has to wait because he may be dependent on some of the outputs from the previous guys, and then it can work on its stuff. Similarly, whenever you are working on something, like something important comes up, you stop it, you keep some information so that you can come back and work on it. So that's the basic use of a stack. So we'll start with one example, very simple example. Like, for example, you have been given number, say, like 1, 5. I will change the number depending on what I want to demonstrate. I haven't thought about an example yet, but say 1, 5. And what I'm interested in is to figure out the first left guy who is smaller than me. So for in this case, 1 is the leftmost guy, so he can't say anyone is smaller than him. So we can choose any number. Normally we choose -1, so I am fine with that. Like let's call it -1. For 5, how will he know that what is smaller than him is, there are two ways. The brute force way, like, okay, when we are at 5, we can continue going leftwards, right? So what I'm saying, like you are given an array, like many values. If I want to see, okay, what is the leftmost guy which is smaller than me, then what is the brute force way you can do? You can just start a loop from here. You go back in this direction and find who is the first guy who is smaller than me, and that's the output, right? Is that clear?
Yes.
Great. In this particular case, like 5 can look at the element towards its left because there are only two numbers and say, hey, actually one is smaller than me. So that's fine. What about if 2 comes? If 2 comes, now 2 cannot just look at its leftmost guy and make that decision. So for this guy, he has to make as we talked about, brute force way, he will go check 5 and then he will go check 1 and then he can make a decision. But the important thing is, having 5, will it help us ever? If 5 was not here, for example, and we were suppose having this value on a stack, suppose 1 came here, then 5 came here. As soon as 2 came here, I looked at the stack top and I say, hey, actually 5 is not smaller than me. So let's pop it out, and then I will check the peak of this. Luckily it's 1, so I will say 1 and we'll insert 2. We'll see why we are doing that. Because now suppose 6 came. So when 6 came, he doesn't need to go through anyone else. He can just look at number 5, whatever is on the stack top, and he can make a decision. So in that particular case, we will add 6 and we can continue moving the same way. As soon as someone greater comes, no problem. But if something smaller comes, then we will find a better place for, like, for example, now we have 3, then 6 has to be kicked out and 3 will come here and 3 will look at its before inserting what was just before him. So we can say, hey, the next guy was 2. If you process this way, then what is the time complexity for this algorithm?
O of n.
O of n, yep. And space complexity also O of n. In this particular case, in the brute force way, what we were doing, we were starting from every place and going all the way to left, and then it will be what? O of n square and no space, right? Okay, so that is, if that is clear, then I will tell you something. Is that clear so far?
Why space is O of 1?
In this particular case, it's already given, so I'm not counting a space for the input, but you are iterating from starting with any I going towards left, checking one by one who has value less than me. So do you need to store that value or not in this particular brute force approach? You don't have to, right?
So yeah, it's O of 1 because we are iterating over the same array. We are not using any additional memory.
Okay, thanks. I was thinking O of n because array is already there, that n number of elements.
Yeah, so when we talk about space in general, we talk about the extra space you used, for that. So if the input already has something, you can ignore that. That's what I clarified also. But yeah, now based on that assumption, now it's O of 1. Is that fine?
Yeah, thank you.
Okay, yeah, no problem. So far so good. We are on track so far. So now look at this, like the stack we were building. So what we are doing every time, what is the eventual current state? It is 1, 2, and then 3. So at each point of time, what we are doing, we are maintaining increasing stack, right? So we also talked about it earlier, like in previous session about intervals. When things are ordered, you can make some observations which helps to solve like a lot of problems. So in this particular case, just by keeping things like, increasing from left to right is giving me some information which I'm able to use to like, better to use it, get a better time complexity. Because I know that if something is uh, bigger than 3, for example, then I need to check it with 2 or 1 or anyone. So we always have this kind of like, data where we just maintain those values which are useful for me. Anything unuseful, we just remove it. That was the concept I was trying to talk about here. When in the function stack, you keep things which are useful for you. If something is not going to be useful, we can just remove it and continue with the like, next guys. So that's the like, big picture. Now we will talk a little bit in detail about this concept. So our whole session is going to be about this thing. So the session should be actually called monotonic stack. We are going to talk. So the brief overview is we'll go through one basic thing which I want to talk about next, and then we have like 8 problems. I don't know how many we can do it, but I have submitted solutions for each of the problems, and also the basic which I discussed, it's already shared. So after the session, you can go through it, you can debug through it. What I don't want to talk about too much in detail is like optimizations, because okay, we are using a stack here, but can we do things without using any stack? Maybe we can, but then the focus will change. So the entire focus is after this session, you should start to think about monotonic stack, how to use it. And since these are all Leetcode questions, I'm pretty sure this will come often in other sessions. Then we can talk about all the different approaches to solve like, the same problem, where monotonic stack could be just one of the possible solutions. Maybe there are better solutions. So is that fair? I just want to make sure that we optimize the use of our time here today. All right. So with that, I will give you an example, like, array 8, 6, 4, 5, 7. And what I'm interested is a couple of things. First, I'm interested in give me first smaller to left. Second thing, I want first smaller to right. Third, I am interested in first larger to left. And the last is first larger to right. So we have to fill this value together. Once we will fill this value, we'll know that we know the problem, and then we will see how to derive this. And we can have the same thing, like if there is no value which is like matching this criteria, we'll put -1. So for 8, we'll start with this guy. work with me, like someone should be like, if you have figured it out, tell me, what is the first smaller 2 left for 8? If it doesn't match, we will put -1 there, by the way.
-1.
Great. So -1. For 6, what is the first smaller 2 left?
-1.
Great. For 4?
Same, -1.
Perfect. For 5?
4.
Excellent. For 7?
5.
Okay, so that's clear. So now we will do the same thing for first smaller to right. So let's fill this value. First smaller towards your right. So for 8, who is the first smaller towards its right? 6. For 6, it will be
4.
4. For 4, it will be what?
-1.
For 5?
Same, -1, -1.
-1. Great. Now first larger to left. So for 8, first larger towards its left. There is nothing towards its left, so -1. For 6, first larger, so 8. For 4, first larger is 6 towards left. For 5, first larger towards its left is still 6. For 7, first larger towards its left is 8. And here, first larger towards right. So for 8, 8 is the biggest number, so I know that -1. For 6, I think it could be 7 here, towards right. For 4, the first larger is 5. For 5, it should be 7. And for 7, there is nothing towards its right, so it's -1. Okay, so now we have this value. If you guys remember, we kind of solved similar problem where we were probably doing one of this, finding probably one of this. So if we can understand this concept, we are basically going to solve 4 problems in one go. And also we are going to derive understanding which will help us solve more problems. So now with that, like, let me erase this and work with you to derive some, like, some important things here. If anybody has any problem to understand this, ask now. We can wait for some time. We can go through it. We are good? Okay. If we are good, then like, okay, that's fine then. Let's go through it. One observation. When you have points in increasing order, may not be linear, so don't think it's in a line or something, but something like this. So this is the case of increasing stack as we were looking at it earlier. Suppose the rule is that whichever guy comes next should get added to this particular configuration. Maybe think is like, this is the height of the people, and my height is actually, I'm falling somewhere here. For example, I'm the new guy which needs to be inserted, and I'm falling here. So to maintain this order, what we have to do, we have to remove these 2 guys because I have to be the last guy. So these guys will get removed.
Your cursor is not on the screen. Okay, I got it.
Can you guys see it? Others?
Yeah. Now I am able to see.
Okay. So I will repeat the same thing again to make it clear. So we had increasing height, like people are arranged in that way so far, and it's my turn. And the thing is that I will always be the last guy. And also we need to maintain the increasing order. So I was this guy, for example. So you have to remove these 2 guys, right? Because if these 2 guys are there and I am the last guy, we cannot maintain the increasing order. Clear?
Yes.
Great. So now when I got inserted here, what information I can note here that, okay, towards my left, this guy is towards my left. So I can immediately put in my notes that, hey, the leftmost guy, like, or first smaller to left, is whatever is on the stack so far. This was our stack basically. We are putting this value, and then I came here. So I kicked out these two guys and I am on top now. So for me, I can just note whatever is currently on top before I get pushed on it. That is the guy who is the first smaller to left. Is that clear?
Yes.
That's good. Or maybe let me give example. So 1, 2 example means better, the easier to understand. 5, 7. My height is suppose 4. So in the beginning, you had this thing 1, 2, 5, 7 on the stack. It's my turn. My height is, for example, 4. So we kicked these two guys out, and now the configuration is like this. So for me, I can say the first guy towards my left is whatever is on the peak. Because when I kicked these two guys out and I didn't insert myself, this guy was on the top. So I can easily say whoever is on the top is the leftmost guy, at least for me, like who is smaller than me. So that is one information. And we already talked about it previously. Now the thing is, can these guys who got kicked out, 5 and 7, can they make any useful information? Can they note anything useful?
Maybe like when they are kicked out, they know the top of the stack, and they know like what's the number which is smaller than me.
Yeah, they knew that when they were actually inserted itself, right? They knew that.
Yep.
That's right. But during this particular event, when I am being inserted, can they note anything useful information here? Can they say anything about like who is the first smaller guy to him towards right?
Yes.
Or
makes sense.
Yes, it is. The current one is the smallest one to the right.
exactly. So that's a very useful information, because now when they got kicked out, still they can also make some useful information that the guy who is coming now, like in this case me, they can put, hey, actually the first guy who is smaller than me is the guy because of whom I got kicked out. Think it as like a rank in an exam. So first, second, fifth, seven, and then I came with a fourth rank, for example. So these guys can say, yeah, the first guy towards my right, first smaller rank towards my right was this guy who had rank 4. Is it
Makes
clear?
sense. Makes sense.
Awesome. So these two observations we made. So we now know with first rule while inserting. So while inserting, when I am popping out other guys, they can also add something to their index, some important information. And once they got removed and I got inserted to my position, I can also put my value that, hey, I know whichever is on the stack now, he is towards my left and he is smaller than me. So in this case, what I am saying, I will say, so first smaller to left for me, for 4, I was 4. So for me, I will say first smaller to left is 2, because when I got filled in here, 2 was towards my left. Finally, he was on the top when I got inserted. For 5, when he got kicked out, he know who, because of whom he got kicked out. So he can make this claim that first smaller to right was 4. Same with 6. 6 will also have this same thing. Like first smaller to right is 4.
I believe 7.
Oh, sorry, 7. Yeah, thanks. 7 had the same thing. Great. So if this is clear, then we go to the next one. Is this very clear? If not clear, feel free to ask, because this is more important than doing questions, by the way, guys. So
Hey, Roger.
yeah.
I have a question. So after 7, if 8s come, like
Mhm.
8, then because we popped out 5 and 7 is smallest number from 8. So but 5 and 7 is not in stack right now.
Yeah, so let's like, for simplicity, we had this arrangement, for example, 1 2 5 7, and then I came, right? I came as 4.
Yes.
Now you are saying 8 came.
Yes.
So when 8 came, his like, first smaller to his left is me actually. 5 7 doesn't matter to him anymore.
Okay, got it.
Got
Yeah.
it?
Yeah, thank you.
Yeah, so that's why when we are maintaining this increasing sequence, we know some of the values. We just talked about it previously, which is of no use. We are going to pop it out. But thing is, when we are popping out, at that time also we can make some useful observation. And I'm trying to demonstrate that with this particular example. Like first smaller to right, these guys can make that observation and fill those values. So for 8, nothing is towards his right, which is smaller, right? But if 2 comes, then what will happen? 2 will pop out 8, right? So 8 can fill, hey, actually I got popped out because of someone came which is smaller than me. So he can do the exact same thing, that I know who is smaller than me towards right. So he will say, okay, I know 2 is the value which is first smaller value towards right. Clear? Any
Yeah.
questions? If not, then we will go to the same thing, but now we will go to the decreasing sequence. So also one thing, when we maintain the increasing sequence, remember, when we are maintaining increasing sequence, then we are able to derive smaller values towards both direction, left and right. Now we will see, if we do the decreasing sequence, probably we will be able to derive the larger value towards left and right. That's where I'm trying to go next. It's the same exact idea, so I think it will be very clear. It's like symmetric case. Okay, so now same story. You have this thing, this configuration. So let's make it same actually. 6, 5, 3, 2. This is the current configuration. 4 got added here. What we want to maintain in this particular case is decreasing sequence. So when 4 comes, 2 has to leave, because 4 has to be the last most guy. So he will pop out 2, he will pop out 3, and then 4 gets inserted. When 4 gets inserted, the important information 4 can make, that who is first larger to my left. So who will be the first larger to 4's left is 5, right? Whichever was on the stack top. So this was the configuration 6, 5, 3, 2. When 4 made the entry, 4, what he did, he popped out 2, he popped out 3, and then before he got inserted, he can look at the leftmost guy and say, hey, actually 5 is the guy who is first larger towards my left. So for 4, this value will be 5. Now same thing, when 3 and 2, they were getting kicked out, what they can claim. For 2, first larger to right is who? Because of whom he got kicked out,
4.
right? Does that make sense, guys?
Yes.
Great. So with this, I think you know the process that, okay, if I have to find something larger, first larger towards left or first larger towards right, then I should build a monotonically decreasing stack. But if I have to get the smaller towards left or smaller towards right, then it's better to build a increasing, monotonically increasing stack. Clear, right? If it is clear, then actually I will show you the code a little bit. I got time to write that code and I didn't find in this particular problem, but I think this will be a very good problem if it is posted for at least, this is the basics of all the possible combinations of these questions, like what you can be interested in, either in left or right direction or smaller or larger. So this particular idea gives you all these 4 things in one go. So
Could we walk through one example?
Oh, yeah.
Initially, let's say the top two array was empty.
Yeah, we can actually walk through this particular example if you want. Do you want me to? Yeah, sure. Let me try to clear some of it. Okay. So 8 came. So I'm interested in building the increasing stack. Okay. So my idea is build increasing stack. 8 came, I put 8 in the stack. And in the beginning, let me initialize all this value to -1, right? Because we know by default everything is -1 if we don't fill any value. Where the, okay, 8, 4, 5, 6, 7. And this is first smaller to left. So I am solving, okay, actually I'm solving this guy first here. And this guy here below it. 8, 4, 5, 6, 7. Okay.
It's 8, 6, 4, 5, 7.
8, 6, 4, 5, 7. Okay, thanks. 8, 6, 4. Actually, let me erase if I can. Also, let me erase this. Yeah. Eight, 6, 4, 5, 7. And by default, if I'm not filling, let's think this is -1, because otherwise the drawing will not look good. Now 8 came, so I'm processing from this side, left to right. Also, guys, we can, depending on the problems, we may choose to run this from left to right or right to left. Depends how the problems ask me to, and gives me useful information. In this particular case, I'm going from left to right, iterating on this. So 8 came, nothing is there. So I will just put it here, 8 on the stack. And my idea is to build an increasing stack. So I always want to see something like this. Any new value should be the biggest one. 6 came. So 6 came, then what we can do when 6 came, so this is a increasing stack. So 8 will be moved out, right? So 8 got kicked out, and then 6 is on the top. Now when 6, we want to insert 6 on the stack, it doesn't find any element. So 6 knows that there is no value which is smaller than me. So this value will remain -1. This is by default -1. So this will remain -1 for 6 because he couldn't find anyone towards him left. Here 8 got kicked out. So when we know that thing, that when something got kicked out, he can claim that there is something towards my right which was smaller, which is the current guy, right? So during this process, he will say, actually, I know someone who is towards my right and is smaller. So 6, he can fill that value. Now we will have 4. 4 will do the same thing. 6 got kicked out. 4 is on the top. And when 4 will look, nobody is towards his left. So -1 will remain here. And 6 got kicked out because of 4. So he can say, hey, this value is 4, which was smaller towards my right. 5 came. So here is 5. So for 5 didn't have to go through kicking out anyone, because whatever was on the stack peak was already smaller than him. So he can fill, hey, what is on stack peak? 4 is on stack peak. Okay, so he knows that 4 is smaller towards him left and is smaller. So 4, there will not be any kick out process here, right? So it will remain like this. Nobody got kicked out. Now 7 came. 7 will maintain this same thing. So when 7 came, it will look at who was on the top. Nobody got kicked out. So it can say, okay, 5 is towards my left, which is smaller. And 5 will have nothing, so nobody got kicked out. And by default, as you know, if nothing is filled, it is -1. Now, if you look at the value which we derived in the beginning, you got the exact same thing. Is that clear? Is that clear, or questions, or we want to go through the second one? We can do that too.
I believe like silence is no questions.
Okay. I hope it is not very tough, but yeah, if it is the first time, maybe slowly you will get used to it. That's why I would highly recommend after this session, again, watch this, go through the problems. And that's the reason I have put the code also this time, that go debug it if it doesn't make sense, because you know a way to figure these things out: smaller, larger, towards left and right, especially the first ones. And that there is a way. So with that, let me try to show the code a little bit. Maybe that will give a better idea. So where was that? Maybe here I put it. So it's the same example, guys. So you would be able to debug it. That's the reason I created this example. This could as well be a very good problem, by the way. What we are doing, we are going to calculate these 4 values: smaller to left, smaller to right, larger to left, larger to right. We pre-filled everything with -1. And then I am building increasing stack and I am building decreasing stack. So my idea is, when I will build the increasing stack, I would have the value for smaller values, like first smaller to left and first smaller to right will get pre-filled. And then same with decreasing stack, these two guys will get updated. So this is a boilerplate code, like just preparing things. This is the most important piece here, these 5 lines. So let's look at it, what we are doing. So we know the numbers length integer array. I already have that value. I created a stack, and then what I am doing every time, if you remember, we went through this process. Whenever a new guy comes, what we do, we check his position that, hey, do we need to kick out anyone? If we need to kick out anyone, then those guys who are kicked out, they can note this information that the person who just came in and because of whom I got kicked out is the first smaller towards my right. So that's this line, exactly same thing we are doing. After we are done, or maybe we didn't need to go through this while loop, then the person, like when I came, I looked who is already on the stack peak, because I know whoever is on the stack peak is the first guy who is smaller than me. So I filled this value and then I added myself to the stack.
I believe like you are adding the indexes here or the actual numbers.
So I am using index in this particular example. And by default also, like, if it is not very complex, try to add index, because when you have index, you can find the number, but not the other way, right?
Yeah,
Yes.
I believe like the indexes makes more sense
Yeah.
because of the lookup. Like we can easily look up in an array
Exactly.
and then figure out the larger or like a smaller one to the left or to the right. Yeah, makes sense.
Yeah. So that's my, yeah, go ahead.
Can we, I don't think we could putting a number not work, right? If we put a number of the value, I don't think it's gonna work because we don't know what index.
That's right. You are right. I said like in general, I can see, hear my voice, guys. Why? Okay, it's better now. In general, even if you think like it's okay to put values, by default, if you put just index, you can access the value, right? But not the other way. So it's always safer to put index. That's the thing I was trying to convey. Does that make sense?
On the example 3, right? So the first larger to the left, it has 8, 6. Is that index or is it a value?
It's the value.
Okay.
Yeah. When I'm printing out the value. So yeah, so this was the increasing stack. Similarly, same logic we talked about for the decreasing stack. We go with a number, we create a stack, we go through this loop. And in this particular case, as I talked about, when we are maintaining the decreasing stack, the guy who got kicked out will be able to note this information that who is the first guy towards my right and who is larger. That would be the guy who is being considered. If a stack is not empty, then before we add to the stack, we can fill this value, who is larger to left. Whoever is on the stack currently is the first larger value, because we are maintaining the decreasing stack. And after that, we are going to do this. So if you look at these two, they are very, very similar. It's not tough to come up with this after you write couple of times similar problems you solve. It's mechanical. Is it clear? This is the core concept. I mean, this is the whole class actually. This is the main thing. So any problem, if you don't understand this, then spend more time on this, I would suggest.
Can you
Can
guys
someone mute it?
yourself? Yeah. I will like Roger. You can mute because you are the host.
Okay, let me try. Is it better now? Yeah.
Yes.
Okay. So
I have a question. Like, can you go to the code?
yeah, sure.
Can you like share your screen? Yeah. So line number 29, build where we are building the increasing stack.
Mm-hmm.
Okay. And from this function, we are able to figure out first smaller to left and first smaller to right.
Right.
Okay. What we use the same code and traverse the numbers in from right to left.
Mm-hmm.
Okay. And use the same logic, like build the increasing stack,
Yeah.
and can we figure out the first larger and first largest to left and first larger to right?
Right. So exactly, like when you are traversing from the right side and you are building increasing stack, so you are essentially doing the same. I think you should be able to derive that. I
Yes.
haven't coded, but yeah, please go through that.
Because it looks like symmetrical, like the way you talked about it.
Yeah.
So maybe using this function build increasing stack,
Yeah.
if we just traverse the array from right to left, we
Yep.
should be able to come up with first larger to left and first larger to right.
Yeah. Worth a try. I
Yeah.
think please go ahead and like, experiment. That's the reason I gave this code, like, feel free to tweak it.
Thanks.
Yeah, no
Yeah,
problem.
I think the main idea is to maintain the property on the stack, as Roger draw. And then when we insert the node, we always make sure the current node is the one on the top of the stack. And the stack, order is maintained. Then it should work.
Yep, that's the core concept. Anyone has any questions? Because now we can move to the questions I posted. We can go through some of them for sure, where we are using the same concept. So that will help you that where it is actually used. I created this problem. It was not in any I couldn't find this exact in like Leetcode or anything, but I try to make it as generic as possible, which can help you apply this concept in different situations. So if there is no question, I can start with the first question for today. Okay, silence means either it's going great or it's going pretty bad. So guys, please let me know. Should we just move it?
Yes.
Okay, thanks. Let's try this then. So what was the chat? Let me check the chat. No problems. Okay, thanks. Now we are going to this problem daily temperature. Now we'll see how we can apply some of it. So have we done this or not? Please share Ripple it link. I have shared everything. Like if you go to the Leetcode practice, today morning, like 2 hours before, earlier, I have already shared everything, the Ripple link plus all the solutions for today. So take a look. All right, back to the problem, daily temperatures. So you are given daily temperatures. So 73, 74, 75, this 73. Your output should be 114 because we are looking for a warmer temperature. Okay, so the problem is when would be the next warmer day? So from 73, if you look, the first day which is warmer is 74, right? So this value will be one day. That one day after today is the warmer day. For 74, it will be again 1 because 75 is the next warmer day. Here is interesting, 75. So for 75, you have to wait 71, 69, 72, and 76. So there are 4 days in between before you will get a warmer day. So that's why for 75, this value is 4, and so on. So now what you are looking at is what is the first day towards your right, which is larger than you. So we can say first larger to right, right?
So we will maintain decreasing stack.
Yes. So now that was my question. You already answered that you are looking at first larger towards it, right? So you will go through this decreasing stack. Is that clear? When we look at smaller, then we maintain increasing stack. When we look for larger, then we maintain decreasing stack. So if that concept is clear, then now should I even draw example, or I can just go through the code? We'll see, we are writing the exact same code. So first my question is like, do you guys have any question on this question?
No.
Okay, let me look at the chat. It's really not easy to find your chats actually. Does anyone have a good idea how to look at chat while going through the session? It's very inconvenient, or I don't know how to use this thing.
Don't worry. Like I was just posting the link to the solution.
Okay, yeah, please someone if can answer that common queries, please, yeah, do that. Thanks for that. So guys, this problem is, we have already solved this, as you can see. So we created a stack here. We went to all the temperature, and we are trying to maintain decreasing stack for the reason we just talked about. So if we find such days, in this particular case, we are saying how many days I have to wait. So that's why you have to put this value in the index. The duration, it's not the index. It's basically like when 76 comes, then 75 could be filled with this value that, hey, I had to wait for 4 days. So this is where we are going to do that. And then we maintain this decreasing stack as usual. It's the same problem, just story has been changed that, okay, it's a daily temperature thing. And now instead of the value, they are telling you the difference, like how many days. So based on the index, you should be able to figure that out. Just the subtraction of the index for these two values will tell me that thing. Fine. Or any problem? Should I draw this to make it clear? Let me know. I can draw this example and I can show you how we can derive that. It's not a big problem.
I guess like it is straightforward.
It's straightforward, right? Exact same thing we already solved, right? That's what I think too.
What is the time complexity O of n?
Yeah. What do you think? Should be open.
Yeah, I was thinking like we have a while loop inside. So
Yeah, it's a tricky, but think about it. The people who got kicked out, they are not again in the picture, right? Because you start popping things out also. So they are not part of your stack anymore. So that's why, even though there is a while loop, it's often.
okay.
Okay. So